question is asking for the critical points of f, given that f of x is equal to x plus 2 times x minus 3 over x minus 4 squared, and f prime is equal to 16 minus 7x over x minus 4 all to the power of 3. The first step would typically be finding the derivative of f of x, but in this particular question it is given to us, so there's no need to do that. The next step would be taking f prime and setting it equal to 0, and then solving for x. So we have 0 is equal to 16 minus 7x over x minus 4 all to the power of 3. When we cross multiply, we eliminate the denominator because x minus 4 to the power of 3 times 0 is equal to 0. And we are left with 0 equals 16 minus 7x. Next, we can add 7x to both sides, so we are left with 7x equals 16. And for our final step, we can divide both sides by 7 to isolate for x. So we have x equals 16 minus 7. So the next question gives us a function and the prime of that function, and is asking us what intervals is f decreasing in. So for step 1, we're going to take f prime of x and set it equal to 0, and try and find a number or multiple numbers that we can sub in for x to make this equation true. So there's two numbers that will work. If you sub in 2 for x, it'll equal 0, and if you also sub in 0 for x, it'll equal 0. So both these numbers are critical numbers we are going to use. For step 2, we use our critical numbers to create a number line. And on this number line, we separated it into 3 separate regions. So by plugging numbers in each of these different regions into our prime of the function, we're able to get a positive or negative solution. So if the solution is positive, we know the values in this region are increasing, and if the solution is negative, we know values in this region are decreasing. So for this particular question, numbers plugged in from 0 to 2 created a negative solution. So we know that values in this region are decreasing. Therefore, we can say that between 0 and 2, f is decreasing. And that would make the answer A. For the next question, we're being asked, which of the following is the value of the function f at a relative minimum? So this question uses the function that we used in the last question, which makes it a bit easier on ourselves. So we're going to go ahead and refer to the number line we created in the last question to make this a bit easier. In the last question, we split up the number line into 3 separate regions based on our critical points. From negative infinity to 0 is increasing, from 0 to 2 is decreasing, and from 2 to infinity it was increasing again. If you think about this, up until the value of 2, the values are decreasing. And then as soon as it is past 2, the values are increasing again. This would mean that 2 is the lowest point possible for this function. This would make 2 a relative minimum. With this information, we can take 2 and plug it back into the function and solve. This will give us a relative minimum of negative 9. So the next question gives us f prime, and f double prime, and is asking us on what interval is f concave upward. So for concavity, we are going to be using the second derivative. So in this question it is given to us, so we don't need to calculate it. So we are going to take the second derivative and set it equal to 0 to find our critical numbers. So when we take 2 minus 2 over x squared and set it equal to 0, there are 2 numbers that can be subbed in for x to make this equation true. That would be negative 1 and positive 1, because both of them squared equal 1, so 2 will equal 2, and these will be our critical numbers. Note that -1 will not be a critical number. This is because -1 is not in the domain of the function. So we can just go ahead and eliminate it. So 1 will be our only critical number. For the next step, we can make a number line and check each region of our graph based on our critical numbers. In this case, we only have one critical number, so we're only going to check on each side of it. From -infinity to 1, I plugged in 1/2, and this worked out to be negative. And from 1 to infinity, I plugged in 2, and this worked out to be positive. Next, we're going to check where f prime of x and f of x do not exist. So to do this, we're going to plug in a number into the function and try and break it. So to break the function, we can make the bottom equal 0 or the bottom and the top equal 0. So in this particular function, we have x minus 4 on the bottom. So in that bracket, we can plug in a 4. So it'll be 4 subtract 4, which equals 0. Obviously, any number over 0 does not exist. So 4 is the number that breaks f prime. For f of x, it is the same thing. X minus 4 to the power of 2. If you plug 4 in again, you will also get 0 on the bottom, which does not exist. Since f of x and f prime of x both do not exist when x equals 4, it is not a critical number. For a final step, we can look at our answer. Our only critical number we had was 16/7, and this works out to be C on the multiple choice. The next question is asking, what is the inflection point of the graph of y equals f of x? So we already know the x value of the inflection point. We know this because the x value for the inflection point is where the function changes from being concave down to concave up. And we figured this out in the last question. This is at x equals 1. So if we take that value of x equals 1 and sub it into the function, we can get the y value and figure out the inflection point. When we do this, we get the y value to also be 1. Therefore, the POI is 1, 1, and the answer is B. The question asks, which of the following is a location of a relative max or min of f? So to figure this out, we're going to take f prime, set it equal to 0. So we have 2x plus 2 over x equals 0. Next, we will simplify, so we get x squared equals -1. And there's no number that can be subbed in for x here that can make this true. Therefore, the solution does not exist, and the answer is E.